Let's have a look at some examples of derivatives of trigonometric functions. The table that you see here is the table that you will get in your information booklet. It includes the power rule, the derivatives of trig functions, and then your differentiation rules. So we'll keep referring back to this. It's a good idea still, though, to know these derivatives off by heart because it makes you more efficient, and it also allows you to identify different parts of derivatives more easily. Let's have a look at our first example. Determine the derivative of y equals sine x plus cos x. Okay, so we know that when we calculate the derivative of a sum, it's the same as the sum of the derivatives. Remember to get your notation right. So here we're dealing with dy over dx, differentiate derivative of y with respect to x. Now my first term is sine x, and we know from our table that the derivative of sine x is cos x. So we write that down. And then we also know that the derivative of cos x is negative sine x. So it's cos x minus sine x. That's our derivative. All right, let's add a bit more complexity to a question. So let's have a look at this one. Determine, now remember this notation is the derivative of that function with respect to x. So we're going to determine that derivative. Actually, we should probably just write it out how we would write it out in a test. So you would start by writing your question. When you actually find the derivative, you no longer write the dx notation. Now here you should be able to see that we are using the chain rule. Actually, let's just fix up that bracket a little bit. A round bracket's crept in there. So we are using the chain rule because I've got a function sine of something with another function inside of it, now 5x. So remember how the chain rule works? You start by differentiating your outer function. The derivative of sine of an angle is cos of that angle. Then we go inside and we multiply it by the derivative of the inside function. Inside we have 5x. The derivative of 5x is 5. We want to go one step further just to make that look a bit pretty. So we've got 5 cos 5x. Alright, here's another one. Again, I'm mixing up different notations here, so make sure you get the correct notation when you're working with derivatives. So we've been told that f of x is equal to tan squared 2x. And again, we've got the chain rule happening here. But instead of just two functions, we're actually dealing with three. Because I can rewrite this f of x as tan 2x all squared. So this is what my three functions would look like. I've got something squared as my first function. I've got tan of something as my second function. And I've got 2x as my third function. So let's have a look at how we're going to find our derivative. First, we differentiate the outer function, which is something squared. So it's 2 times that something. Now I'm going to go and differentiate my inner function, which is tan of an angle. Now the derivative of tan of an angle is sec squared of that angle. So I'm going to multiply it by sec squared of 2x. Then I go inside and I differentiate my inside function, which is my 2x. The derivative of 2x is 2. Again, we can make that look a bit more pretty. 2 times 2 gives me 4 tan 2x sec squared 2x. Alright, let's have a look at this one. This is the last example we're looking at in this video. We've been asked to determine the derivative of 2x cubed sec x. So let's see what we have going on here. We've got the product rule coming into play because we've got one function which is 2x cubed multiplied by another function which is sec x. Remember how the product rule works. I'm going to find the derivative of the first function, so I'm going to find the derivative of 2x cubed, which is 6x squared, and multiply it by the second function as is. Then I'm going to add the first function, 2x cubed, multiplied by the derivative of the second function. If you look back at your table, the derivative of sec x is sec x tan x. And usually you wouldn't be expected to simplify in any way, so we can actually leave our answer just like that.